Welcome back to the channel, guys. Here is another update of our Ultimate Callout Challenge truck build. In our last episode, we introduced you to some big, awesome engines. Taking two, only gonna need one, but we're taking two. Since then, we've been, doing what?
Got the engine stabbed in, and we're working on turbo fab today.
Yes, awesome turbos. Some people love it, some people hate it. I love it. Let's check it out. All right, so this is where the build sits so far. Literally, we have not done near enough videos. We've spent many nights here till 3, 4, 5 in the morning trying to get this thing ready so we can do some testing before the actual event. And the guys are at lunch right now, so nobody's here. So we're like, get the camera out, let's make a quick video, show you where we're at. So we haven't cleaned up anything.
Did you eat lunch today?
I did, I ate early.
I didn't eat lunch, I'm sorry.
You should go on a diet anyway. But so should I. I'm the driver. I need to be on a diet. That's what it is. So the first thing we gotta do is we had to get the engine in place.
We have an 1,135 pound race engine. So anybody that's thinking of racing a Cummins, think about it. Solid block. Okay, awesome. Good work, guys. Let's get this stabbed in this hole. The frame was a little tight for some reason. It might have been because an engine got blown up and the sheet metal got blown off of it. What? But it was a little tight on the motor mount. It's tighter than I've ever seen it, but we got it. And lo and behold, the engine wouldn't quite fit. So what did we do? We had to modify the cross member a little bit further.
Okay, so take one is a failure, but we're close. Just need a little more choppy chop on the cross member. No big deal.
Because the cross member underneath this was really not enough room for the girdles.
We modified it for the girdles, but
enough.
not quite enough.
Let's yank her back out so we can modify it. Do you need to make some paint pen marks so we know what we got to cut and chop?
So we had to pull it back out, cut out some more, put it back in.
Hey, we got some love for Greg Avarella. Look at that. Rinseworks? Sweet, I just noticed that. Love you, man. Greg. Let's see what we did here. So we beat the cross member down just a smidge. That is how you fit a 3/4 inch girdle with factory cross member. Just needs a little massaging. Work on a TV show. That there is a clean second gen frame. No rust. Ready? Whoa. 10, huh?
Now it fits. Really awesome. So then we got to put our turbo together. First thing we had to do for our turbo system is build the hot pipe. That's the thing that connects the manifold charger to the atmosphere chargers. And so that locates everything. Once that's done, then you can just hook it all together. But that's the hardest part of any compound turbo system is your hot pipe, because that locates where your atmosphere turbo or turbos are going to sit.
You know, in the past, we'd had a few turbos blow up and they ripped through the sheet metal with 16 gauge. So I wanted a thick hot pipe. I was like, Todd, we're going with Schedule 40. The problem is any flange you buy, an exhaust outlet flange for GT55, is designed to be an exhaust for sheet metal. So went over to the lathe, started the big chunk of, I think it was 1018 steel. And a couple hours later, I had a GT55 flange that adapted perfect to the hot pipe.
It's the most gnarly flange ever. I loved it. So heavy duty. You know, like I said, when we had some explosions, I never had a turbine wheel leave the pipes, but it definitely ripped the pipes. And we welded and
Or stuck out. We had the shaft hanging out a couple times.
Definitely punctured the pipe. So this is a much stronger setup.
So it's safer.
Yes.
Going for safety.
Going for safety. And yeah, and it fits really well. So we got that big monster piece in, and then we got to locate the two turbos.
So we go back to the lathe. We had a couple nice flanges that we actually got from a Keating machine.
Yep.
He already made them. There's no point in making our own flange for two turbos, so we just bought them. And I think we used 3.5 inch Schedule 40 and made them go right into our same log manifold. Got a little hate on the log manifold. Guys are worried about laminar flow. You know what? The old setup made a lot of power. new one's going to make even more.
Here's something interesting about that complaint. The whole reason I got the idea of the log manifold was from one of these.
That's how the intake is.
Everybody, it's a log, and it has a straight port into the valve. So I don't know why everybody thinks that this can work and that can't. It's going into a log, going into a port, goes into a log, goes into a port. So that's how I actually got the idea originally. Like, well, that would be a lot more compact, and it really worked, man. It worked really well. So to all the people who thinks that can't work, explain to me how this can. Seems kind of contradictory.
The other thing is, this allows us to add a wastegate. So we've added a second 50 millimeter JGS gate on the front of the log. This will let us slow down these chargers a little, do a little bit more power management, because in the past, we haven't really had trouble making power. We've had trouble harnessing it or dialing it back to what the chassis or the race condition wanted.
Talk about that wastegate. You had to make a wastegate piece for that front wastegate. What'd you do to make that thing?
So we had this big Schedule 40 ugly pipe. Well, the problem is you can't put that in a lathe and cut it and clean up, and it looked kind of ugly. So I made a cap that went in the end that I could support with a live center so that I could turn down the diameter and make it look pretty and make it easier to weld on, because I cleaned up all the mill scales, what they call. And then when I got done with that pipe, I was like, man, that's perfect for a flange. This is the end cap for the hot pipe, and we're making a wastegate flange on it. So we started with a big chunk of steel, and we've cut it down into the wastegate. Now we're boring it out, and then we're making it fit the pipe. And we're just going to profile a little to lighten it, and we'll be all done. Custom parts. But I was trying to make it as compact as possible, so I had about a 2.5 inch thick chunk of steel, and I cut a wastegate flange into it, cut it on a nice angle so it's a really high flow. So this wastegate should have basically flow as much as the gate can. The in and outlet on it is, tapered and ported, and it's, anyway, just a fun little project to do on the lathe. It's not something we sell, so don't ask for it.
But it is awesome.
It probably cost us $500 in labor, but at the end of the day, we had a lathe, and I had some steel, and I made it. So there it is.
Ta-da!
So I'm really excited about that. So we really tune in the boost pressure. We're going to tune the drive pressure too. There's a lot of power to be made by keeping your drive pressure down. That's a pressure that's going into the turbocharger. That's a pressure your piston sees. When that exhaust valve opens, that's to push out that exhaust into a high pressure environment. The more pressure you have there, the harder is that piston to push it out. That's free horsepower you can gain by dropping drive pressure. That's the whole idea with these extra wastegates.
Is getting the drive pressure lower. I call it negative torque. Get rid of the negative torque, and it helps. There's also a little negative torque when the injectors fire a little early, but we don't need to talk about that.
Yeah. So on the turbos, once the hot pipe was located, I had to rebuild all the pipes because in August, they all blew up. And the only piece that remains is this guy here. No, actually the one behind you too. That one right behind you, I've inverted. That was part of it, and I've actually turned it backwards now. And so
2 of 20 fabricated pieces
survived
or were able to be reused.
Yeah. I did put a new flange on right here. This was not here last time, but it is from here back as original. And this comes over here to our intercooler, which is still here. This right here my foot is on is our new intercooler mount.
Is it gonna fit? Oh dear. It'll hold Josh.
Last year I had the mount right to the engine because I had it all V-band flanged. But now with these cool vibrant flanges, with you get two connections in a vibrant van gen, there's enough play here that you can really make it work. So I can, with two of these things, I can mount this to the frame and the engine can still move and it won't cause us issues. I actually like this a lot better, a lot more solid, a lot easier to work on, and it's a nice chair if you need it. Also, we've relocated our interior intercooler. We have an intercooler that goes in the cab. We've scooted back a little bit to make some more room for working in the firewall. And I had to remake that pipe going from those 2 turbos into the firewall, so that was a lot of fun. I think, it's definitely an improvement over last time. The last time I built this, like I've said before, was my first time I've ever welded. I had to learn how to weld building this system the first time. And now I'm a little bit better at it, and I know more, so the stuff now is better than it was before.
Okay, so on this nice hot pipe, we changed the turbo setup a little bit. We're still Gen 2 GTX Garrett. GT55 size turbos, but we have two 106s. These make boost that goes into a watered air intercooler in the cab. Those feed a third GTX 55. This is the 33R model, so it's a 98 millimeter. These are 106 millimeter. And then from that, it feeds the other intercooler and goes in the engine. Mm-hmm. In the past, we had two 98s feeding an 88. Now we have two 106s feeding a 98.
And the reason that is because only one of our turbos survived the blow up, and it was a 98 millimeter.
He still spins. Not so spinny.
198 survived, and we decided if we're buying two new ones, we might as well get the latest and greatest.
Which is the 106.
Did we need more air?
Nope.
Nope. So everybody that says, why do we put so much air? The answer is because we can. Why
cool.
do we need 500 pounds a minute of airflow? Because we had to buy two new chargers, and why would we have 490 when we can have 500 plus?
Yeah, makes sense. So we got 198 that's used, but we went through it all. It's perfect. It's great. The two 106s, and we've heard of guys making dang near 2,000 horsepower in one of those.
With one of them.
Was that with nitrous though, or was that fuel only?
I think that was a little nitrous help that that Armor did with. So I don't know what they did fuel only, but airflow wise, a gas guy would say this is a 2,600 horsepower crank charger. Seems like with the math we do, we say they're about a 1,600 horsepower, 1,700.
Yeah.
So we think we have enough for 3,000 to the wheel. That number's never been done though. That's
a big number. It's a big thing to jump. I mean, we're 600 horsepower away from that basically, and UCC is 2,400 been hit basically, or 23, 24.
2470 or something what Baca hit. Well, that was in Salt Lake.
Yeah.
With the good correction. I think the highest at Indy is right about 24 even or 2390. So basically, someone's got to add 600 more horsepower to their setup to hit that elusive 3,000 wheel number.
Yeah, it's going to be tough to do on a chassis. It's been done on an engine dyno many times. To do it on a chassis dyno.
Yeah, engine dyno 3000 is pretty regular for a setup like this. Like, I'll bet if we threw this on anybody's engine dyno, it would touch 3 really easy.
Getting it to the ground on a chassis,
it's way harder. So that's basically the turbo. So fairly simple setup. We've had really good luck with the Garretts. That's why we're running them.
So the Garrett GT55 is the largest ball bearing turbo Garrett makes. There's nothing larger. So it's a very robust turbo in that it's a ball bearing. The thrust capacity is way higher than a typical journal bearing turbo. And so they're really nice units.
Another thing, we weren't happy with the oil pressure numbers. So we went with a larger oil filter. We thought maybe the factory filter was too restrictive and maybe going into bypass or wasn't filtering the oil well. So we went with this no limit external oil filter. This takes a big monster filter designed for like a tractor application, and got an external regulator on it so we can set the pressure wherever we want, and just another little cool add-on that did that. We stayed with the dual catch cans like we had before. These nice vibrant catch cans, we love them. They pull crankcase pressure, one out of the valve cover, one out of the front. They go in the catch can, which separates the oil mist from the blow-by, essentially. And then out of these, they come to the exhaust, and we have Venturis. That high-speed exhaust that's evacuating creates a little vacuum on these systems, and it pulls a little vacuum, and it evacuates that pressure. Then at the end of the run, when all the oil's built up, there's 2 drain lines in the bottom with a check valve, and the check valve makes it so crankcase pressure doesn't push oil out of the bottom of the oil pan up and out, because we've tested it. You can dump about 2 quarts of oil
real quick
in one dyno run through these things. And so with the check valve down there, it can't suck oil out of the sump, but once it shuts off, it drains the oil that's caught in the cans back automatically. Because once again, we found if you don't drain these after every run, these fill up and it just starts wicking oil like crazy out of there because you don't get the separation. So something that took a lot of trial and error to get perfected, but we love it, so we went back with the exact same
I actually
setup.
made oil cans in the past, trying to figure out ways to do it, and they worked okay, but with this system now, with the simple separator and the simple drain, I freaking love it. It's so simple, and you never have to drain your oil, and you never have leaks. I mean, it's so awesome. I really like this setup.
Something else we were struggling with is the air shutoff.
Oh,
We wanted
yes.
a mechanical air shutoff, and we wanted it tied into the fuel shutoff so they're both on the same lever. We didn't want Todd trying to get trained to hit 2 shutoff devices. So the guys, Dustin Jameson actually, they came up with this great idea. They made a little cable block over there, and it basically splits one. We actually used a parachute handle
Parachute handle and parachute cable.
and parachute cable that
Actually,
comes
it might be a bicycle cable. No, I think it's a parachute cable.
parachute cable there, and then bicycle cables, so they're replaceable, that come up to the air shutoff. But we have a mechanical air shutoff. That's one we got from Archie Stallnicker. I don't know if SRS is still around. I heard from Arch from forever, but
But
we're using
that guy
his-
had a passion. That guy had a real passion.
So we've got his fancy air shutoff, and yeah, it looks good there, and we've tested it. It works well. So when you pull the cable, it dumps the 3-way dump, which basically diverts the lift pump pressure from the fuel pump on the front and sends it back to the tank return. Basically, it starves the injection pump when that is pulled, and then the air shutoff starves the engine of air.
So we've got 2 ways to turn it off this time. Should something happen, we're hoping at least one of them works. I think they'll both work just great, honestly. These are both a big upgrade from last time, so we should be able to turn the truck off.
Before we
need
had an air shutoff that worked
to. Electronically actuated.
electronically 4 or 5 times we tried it, and then the one time we really needed it, it didn't work. So
Back to mechanical.
Back to mechanical.
Yep.
I'm trying to think what else we did. We got some big injection lines we already told you about, so we had to make some little custom clamps for it.
Oh yeah, these are really cool. We'll probably go over more of this.
After I made them, one of my guys informed me they look just like the clamps that Weston made for the OptiTorque engine at PRI. I had no idea. I'd never seen the engine, so I didn't copy you, Weston, but at the end of the day,
They work.
if they look the same, they work great. I guess great minds think alike.
He probably doesn't think you have a great mind.
Got a Lexan windshield in here from Fleece. Looks
Lexan
great.
windshield.
I think Shield is the name of the manufacturer that makes them for Fleece, but that took a little learning to. I guess you can't use polyurethane with Lexan because the solvent. So regular windshield sealant isn't what you use. So they recommended an RTV, so we used a silicone. So we could seal up the windshield because, let's be honest, sometimes this thing gets hauled open trailer to an event and all you want is water coming in the windshield and ruining all of that electrical that Lawton works so hard on.
Sometimes it starts on fire. You don't want the fire.
And if you're looking for fabrication components, we're really happy with these Vibrant components. That's why we reused them. So the Van Gens, all of their braided stainless, it's top-notch stuff. So we've had really good luck with Vibrant. So hit them up if you're looking.
I will say this about Vibrant. We have, we went to SEMA a couple years ago and we saw, go to the Vibrant, but there's Fragola, there's Earls, there's a lot of different companies that make basically the same thing. In the Vibrant booth, they had what? A diesel drag truck. Nobody else cares. And Vibrant's at all the events, and they go in and they cover this event. They do a whole video about UCC. So if you're into diesel, support the guys who support you, because Vibrant is the only one I know of in the fittings category who's actually supporting diesel motorsports. So
Directly,
that's
other
why we
ones-
use them.
Other components get used, but they support us, so we support them.
Yeah.
Like,
So there are other companies, but that's why we use Vibrant. That's why we tout them a little bit, because they actually are supporting diesel motorsports, where the other companies just don't care.
it's like these HD clamps. They didn't have a need for HD clamps when everything was gas boosted. You get 60 pounds of boost on a gas application.
That's massive.
I mean, you're massive. The top guys are maybe making 90. I guess there's a couple compound guys down in Australia doing about 110 pounds of boost, but they're not doing 200 pounds of boost. Their old clamps, you take them to 200, they break. What did we tell Vibrant about it? What do they do? 2 months later, they come out with these HD clamps and they go, here you go. They go to UCC and give them to every competitor, just the updated clamps, because he said, hey, we've had a couple diesel guys have trouble. And like I said, that's class act. That's a company that cares about motorsports when they will go make a new product for, the ugly stepchild diesel racers.
Yeah, that's what we are.
But like I said, it's getting more popular, and yeah,
So anyway.
support Vibrant. They're awesome.
They really are. All right, well, I hope that was informational, entertaining to you. We spent a lot of time on this build. Spent a lot of time in the turbos. Had to redo the whole thing. When we blew it up, like I said, we had to redo the whole entire thing. And so I spent a lot of time on this guy.
A lot of work.
Yeah, when you guys are building race trucks in your garage, it's a passion you have to have, because the amount of hours it takes. I'll bet you with all the guys we've had work on this so far, we put a year's worth of man hours in the last month. I mean, we have just been cranking it. Maybe not a year, but a lot of man hours going into one of these trucks. So anyway, thanks for watching. Thanks for tuning in. Thanks for supporting our build. Hope to see you at UCC. Hope to see you supporting us, and thanks for all your support already.
Next video, startup.
Startup. Not blow up. Just startup.
Ready? Yep, go for it.